Here are important concepts to deal with inverse trigonometric functions. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll again consider a very important question which is based on inverse trigonometric functions. It is extremely important for students to understand trigonometric functions and their inverse if the requirement is to prepare for calculus. So in pre-calculus, this is one of the good topic to review. We have composite functions here. We are talking about functions of functions. A, tan inverse of 2 cos 2 sine inverse of half. So that is one which you need to evaluate. The other one which you need to evaluate is related with sine inverse of cos tan inverse of minus square root 3. I'd like you to pause the video, answer this question, and then look into my suggestions. As a hint, what I've done here is also taken the special triangles, which is pi by 3, pi by 6, pi by 2, where the sides are, as you can see, square root 3, 1 and 2. And the other one, which is pi by 4, pi by 4, pi by 2. Correct. Now these triangles will help you to relate to the values, right? Now let us see, how do we solve? Well, the strategy is very clear. We have to start from inside out, right? That is first thing. So let's take first tan inverse, right? So we have tan inverse of 2 times cos of 2 times sine inverse of half. So when I say inside out, we need to first figure out what is sine inverse of half, correct? Now sine inverse of half, you can look into this particular triangle, a special triangle, and you know sine inverse of half is pi by 6, right? And therefore, we could write this as equal to tan inverse of 2 times cos of 2 times pi by 6. Make sense? Correct? Now we can just simplify this to rewrite the expression as tan inverse of 2 times cos of 2 pi by 6 is same as pi by 3. Now cos pi by 3 will give you a value, which is, again getting back to this particular triangle, cos pi by 3 is half, right? So we can write this as tan inverse of 2 times half. That becomes tan inverse of 1, and as you know, tan inverse of 1 is pi by 4, right? The other special triangle. So tan inverse of 1 is pi by 4. So do you see how we have calculated the value? So these are the steps to be followed. So I hope it is absolutely clear. Now let's do the next one, where we are not talking about the angle, which is minus, related to minus pi by 3, okay? So let's take up the second example, which is sine inverse of cos of tan inverse of minus square root 3, correct? Make sense? Correct. Now, when we are saying minus, that means we are talking about the quadrant 4, right? Since tan inverse, we always look into pi by 2 to minus pi by 2 to pi by 2, right? So this happens for pi by 3, where the angle is minus pi by 3, right? So that is the value. So let's evaluate this value and rewrite. So we have this as sine inverse of cos of So tan inverse of minus square root 3 will be minus pi by 3. Make sense? Right. Now cos is an even function, and therefore I could write this as sine inverse of cos of pi by 3. Perfect. What is cos of pi by 3? Cos of pi by 3 is half, and therefore we have this as sine inverse of half. Sine inverse of half is pi by 6, right? So we get this solution as equal to pi by 6. Makes sense? See how we go from inside out to get the solution. Well, that is a very neat way of doing it. Well, in case you want to learn from me, send an email on the address given. Feel free to write your comments and suggestions. If you like and subscribe to my videos, that would be great. Here is complete solution of what we just did. Perfect. So both the questions, which were composite functions for inverse trigonometric functions, right? You have to work from inside out. Perfect. You have to work from inside out and go step by step, take care of special triangles and solve as shown here. I hope it makes sense. Thank you and all the best.